Hey there, folks. This is quiz number 6 for your intermediate algebra. It'll serve as a practice exam for your intermediate algebra class. And I'm just going to jump into it. There are 15 questions for this particular quiz. And for number 1, the question that I have is x to the 14 over 15 power. They're asking how to rewrite it. When we have a rational exponent like this, the denominator is the index. That's the part that goes there. So that's just a nice simple rewrite. So again, the denominator is the index, the numerator is the exponent. Number 2 over here. My number 2 is x to the 4th. Again, you may have different numbers in yours, which is fine. The process will all be the same. Y to the negative 7/8 and x to the negative 1st. And what I'm going to do first is I'm going to combine up my denominators because I have 2 x's there. And when you multiply, you add the exponents. So -1 plus -1 is x to the negative 2 power. Y to the negative 7/8. Now I'm dividing, and when you divide the same base, subtract the exponents. I want to be really careful with that. X to the 4 minus -2, and y to the 1/4 minus negative 7/8. Be real careful with that double negative. This gives me x 6th. 4 minus -2, that becomes +2. And y, I'm going to get a common denominator. That's going to become plus. Common denominator here is going to give me 2 over 8 plus 7 over 8, which is x to the 6th, y to the 9 over 8 power. And that is my final answer. Number 3, we have a simplify. I'm going to do square root 45, x to the 6th, y to the 9th. And the idea is we want to find as many perfect squares as we can here. 45 is going to factor into 3 squared times 5. X to the 6th. Basically what I'm going to do is I'm going to divide the exponent by 2. And 9 doesn't divide by 2 evenly, so I'm going to split it up so that it does here. I want to point out the ones with the even exponents are going to come out. And the ones that don't have enough, they don't have a perfect square, are going to stay inside. This becomes 3 x to the 3rd, y to the 4th times the square root of 5y. And you'll notice all the exponents here of the ones that came out of the radical are exactly half of what they were. And that is my final answer there. 3x to the 3rd, y to the 4th times the square root of 5y. You don't have to put the dot when you enter it in, but I wanted to make it clear that that wasn't y, 4th root of 5y. So I like separating it out like that. Number 4, I have the 5th root, 125. X to the 4th, y to the 3rd times the fifth root. As long as the indices are the same, I'm going to be able to combine them up here. 25x y squared. And I'm going to note that I can make one giant fifth root radical. 125 times 25 is 3125. X, I'm going to add the exponents. 4 plus 1 is to the fifth power. 3 plus 2 is to the fifth power. Now, to be fair, I can pull the x and y out. But the 325 is actually 5 to the fifth power. Let's verify that. 5 raised to the fifth power. There it is. So actually, everything gets to come out. 5x, y. And that is my final answer. Number 5 is multiply. And here we're going to FOIL. So this is the first terms. The outer terms are going to be 19 root 10 plus the inner terms, which are here. That's just going to be root 10 plus 19 root 4. And we are going to be able to simplify here, and I can even combine those up. Nineteen times 2 is 38 plus 5 is going to be 43 plus 20 root 10. That is my final answer. All right, number 6. Number 6, we have a perfect square. And I'm going to use, I'm just going to FOIL it together. There's a rule that we could follow, but I'm just going to FOIL it together. The key here is don't just give a square to both. That's definitely not going to work, for sure. The first terms, 4 times 4, 16. The outer terms, 20 root 3. Remember the terms on that are outside the radical can multiply. The terms that are inside the radical, they can multiply, but the outsides can't multiply with the insides. So the outers, I get 4 times 5 is 20 root 3. The inners, 5 times 4, 20 root 3. That's where those two come from. And the last ones are 5 times 5 is 25. Root 3 times root 3 is root 9. And you can see that's going to come out of the radical there. So I combined up my two like terms there. Root 9 is 3. 3/4 is 75 cents. And 16 plus 75, that's going to give me 91 plus 40 root 3. Let's verify that. There it is. And that is number 6. Number 7 is negative 50 over root 10. And what I'm going to do there is I'm going to rationalize the denominator, meaning I'm going to get rid of the radical in the denominator by multiplying the top and bottom both by root 10. Root 10 times root 10 is root 100, which is just 10. And that's the point, is we're multiplying the radical times itself to get rid of the radicals. So now the radical's gone from the denominator, and now I'm going to notice that the 50 and the 10 reduce. All right, next up. Doing fine. So we're going to continue to rationalize our denominators. What I'm going to do is I'm going to multiply the top and bottom. This time I can't just do it with root 2, because if I multiply root 2 here, that'll work there, but then I have another root 2 here. So I haven't gotten rid of the radicals yet. So what I'm going to do is I'm going to force a difference of squares and multiply by what's called the conjugate. 5 plus root 2, its conjugate is going to be 5 minus root 2. Up top, I'm going to have to FOIL. Down below, I have a difference of squares, which is nice. Again, I'm foiling first, outer, inner, and then last. Down below, I have a difference of squares. So I can take the square root of the 4, but these two I can combine up. Five squared is 25. Root 2 squared is just 2. The radical and the squared, they cancel each other out. They're what are called the inverses. We'll learn more about that later in the semester. And that gives me my final answer there. So I'm going to try to save us some paper and use the back of the sheet. And we are to number 9. Now you'll notice that I don't have the radical by itself. Here's our equation. So what I'm going to do is I'm going to add the 1 to both sides. Now to get rid of the square root, I'm going to square both sides. Again, I can't just distribute the squared symbol. I have to actually FOIL that out. Here, the radical cancels out. here, when I do x plus 1 times x plus 1, I get x squared plus 2x plus 1. There's also a formula that can help you with that. The key here is that I now recognize that I have a quadratic, which means I have to get the whole thing equal to 0. Although I could move this to the left, I like keeping that lead coefficient positive if possible. This gives me x squared minus 7x plus 12 equals 0. I'm going to carry that up to here. We're good. I'm going to go ahead and factor that. If you need to use a longer process to do that, that's fine. The way I teach it is I do a diamond and by grouping and the whole thing. However you were taught to do it is fine. Use the zero product property. And this gives me that x equals 3 and x equals 4. Now we do need to check this. When we square both sides, we're actually slightly altering it potentially. So we need to make sure that we're good to go on this. So when I plug 3 in there, 27 minus 11, 27 minus 11, 27 minus 11 is 116. Root 16 is 4, 4 minus 1 is 3. We're good. X equals 4, 36, 36 minus 11, that's going to be 25. Root 25 is 5, 5 minus 1 is 4. Both work. If you need to write that out to verify that, that's fine. It's very possible that we get 2 answers and one of them we got to throw out. That's not unusual. So just double check that. Next up, we got 10. Which is the 4th root, 2x minus 8 equals 3. Now that I have a 4th root, that means to get rid of that, I need to raise everything to the 4th power. Three to the 4th power is 81. Now divide both sides by 2. (89/2) does not reduce. So I'll leave it there, or you could rewrite it as 44.5. Both are correct answers. Number 11. I'm going to show you what's on my screen by changing what we're viewing. Here we go. It's a word problem. Here we are, number 11. A utility pole is 9 meters high and a cable is stretched from the top of the pole to a point on the ground that is 5 meters from the bottom of the pole. How long is the cable? All right, let me switch over. So we have a utility pole that is 9 meters high. And the cable is stretched from the top of the pole to the ground. So this is the pole. This is the cable. And this is the ground. We're assuming the pole stands at a 90-degree angle. And the pole is 5 meters from the bottom of the pole. So we're 5 meters here. And what we're looking for is that. So we're going to be using the Pythagorean theorem. This is a leg, that's a leg. Here's the hypotenuse. So leg squared plus leg squared equals the hypotenuse squared. Let's see, that's 106. So I'm gonna have to do the square root of both sides. Now, to be clear, even though it should be plus or minus, we're not really looking for a direction or something, a negative answer in this case. I do want to do square root of 106. And that is about 10.2956 meters. Problem doesn't say how many digits to go to, so I went to 4, just in case. All right. I'm gonna scooch that up. And number 12, it's actually 2 problems. The first problem is to add. And here we're dealing with complex numbers. I, if you remember, is the definition of it is it's equal to the square root of -1, which initially sounds really weird. Now, because it's plus, we can ignore the parentheses here. So 11 plus 24 is going to be 35. -14 plus 20 is positive 6i. And you'll notice that we have written this in standard form. If you recall, standard form for a complex number is a plus bi. The second part of this is subtract. And this is slightly more complicated, not much. But here I'm going to distribute the negative. So the parentheses do matter in this case. The addition, not so much, but the subtraction, it does. And 11 minus 24 is going to be a negative. Let's see, that's 1, 3, 13. And here, I'm going to get, let's see, that's 34i. And once again, you can see we are writing it in a plus bi form. (13), we are multiplying 2 complex numbers. Which just means FOIL. So 1 times 6 is 6. 1 times 9i is plus 9i. Negative 2i times 6 is minus 12i. And then negative 2i times 9i is negative 18i squared. Now, we need to remember I squared is -1. So 6, I can see here I'm going to combine up these two, minus 3i, minus 18 times -1. which becomes 6 minus 3i plus 18. So it changes the sign at the end there. 6 plus 18 is 24 minus 3i. And once again, we have written this in standard form, a plus bi. And I'm going to chop that off for 15, and 14 I'm going to start here. 14 is going to be very similar to a previous one that we did, where we're dividing. And what I'm going to have to do is multiply by the conjugate of the denominator, which is, in this case, -4 plus 7i. You only change the sign in the middle, not the outside sign. That's a really common mistake. Up top, I'm going to FOIL first terms, the outer terms, the inner terms, and the last terms. Down below, I have a difference of squares. So lots going on here. Here in the middle, I'm going to add up the two like terms here. That I squared, if you remember, is a -1, and it actually changes the sign. So instead of minus 35, I'm going to write that as plus 35. Down below, -4 squared is 16, minus 7i squared is 49i squared. Now up top, -28 and 35 is 7. And I squared is -1, remember, so that changes that to plus 49. So 16 plus 49 is 65. And if I want to write this in standard form, which I do, I'm going to break this up. 7 over 65 plus 69 over 65i. Once again, that is our a plus bi, which is our standard form. All right, last problem. Here we have a power of I to the 23rd power. And I'm going to do 23 divided by 4. And the key here is the remainder, which means I to the 23rd is the same as I to the 3rd. And the only ones that you need to remember are the first 4. I equals I squared equals -1, I to the 3rd equals -I to the 4th is 1. So we know that I to the 3rd is -I. And that is it. Thanks, and good luck on your test. I hope you nail it.